Good evening, excellent biology students. Hope you are doing fine, and I hope you had a wonderful day. So please let me know if I'm audible enough. Let me know if I am audible enough. Good evening, Frida, Mary, Anna, Matilda, Mary Rose, Toran. Toran, what are you doing here? Former student. Mutemwe, Annie, Sender. All right. Audible. Wonderful, wonderful. I hope everything is clear. Are you able to see what is on your screen? Make sure that as you are watching this live class, my excellent students, your video is at high quality. Okay, so that things that are on the screen will be clear on your end. Okay. So, and make sure that as you are watching this live class, your phone is in landscape mode, not portrait, but landscape, so that you'll be able to clearly see what is on the screen. Good evening, Lamek, Sasha. I hope we had a good day. I hope we had a wonderful day. Okay. Otherwise, at least in local convula. So it's a good time because it was just too hot. It was just too hot. So before we start with our live class, I want to mention something to my online students. Okay, I want to mention something to you, which is learning online. Sometimes it can be tricky. Sometimes it can be hard, especially that. And one hard something that is hard when it comes to online lessons is being committed. In as much as you have registered for the online classes, you have to be committed, because you'll be feeling lazy. Most of the times you'll be feeling lazy to attend the live classes. You'll be feeling lazy to watch the tutorial videos. But if you are feeling lazy, it won't help you. Okay. So I want to encourage you to be committed, participate. That's one thing that is going to help you. As in this live class right now, there's a former student, Toran. Please, how were you helped? Toran was one student who would participate. She's a former student. She cleared her biology, and it it was because she was committed, she was consistent. She would attend live classes, she would submit the assignments. If there's a test, she will write. Those are the things that you have to do. If you go for work, you can make time for these live classes. Okay, so if you know to say, oh, at 20 hours I won't be available for the live class, when you're available, watch the live class. Okay, watch the live class, because right now as I am teaching, this live class is being recorded. Once we are done, it will still be there, and you'll be able to watch the live class at your own free time. So be committed, my students, and be consistent. You are wise by starting classes early, because biology is bulky. So you have to be consistent. Have a study timetable. Show up to your studies. Do not be lazy. Laziness is going to kill you in the incoming exam, which are going to be written next year. So make sure that you are committed and you are not lazy. Because if you are lazy, online classes will be hard. You have to show up. Show up, because with online I can't really tell who has attended, who hasn't attended class. I can't tell. So this is why you have to be committed, and you have to be honest with yourself and show up. Okay, so I just thought of mentioning that, because it's usually sad where I'm having a live class and only 18 students have attended, but in the group we are above 50. All of us are supposed to be here, and if we can't make it for the live class, at least watch the recorded one. That way you'll be helped. Okay. So I hope we attended yesterday's live class, which was on Facebook. In that live class, I was introducing I was introducing enzymes. I talked about, we defined an enzyme. We also looked at the types of enzymes, and we also looked at the characteristics of enzymes. So today we're going to move further by looking at the factors that affect enzyme activity. Okay, that is what we're going to focus on in tonight's live class. But before I begin, am I audible? Are you able to get what I'm saying? And is everything clear on your end? Someone to just confirm if I'm still audible. All right, wonderful, wonderful. I'm audible, wonderful. So just to run quickly, just run through the characteristics of enzymes. Yesterday we said that most of them are protein in nature. Okay, enzymes are protein in nature, meaning they are proteins. And then enzymes are catalyst. They are catalysts, and we defined what a catalyst is. We said it's a substance that speeds up the rate of a chemical reaction. And then we also said that they catalyze both forward and reverse reactions. We also said that they are specific. Okay, enzymes are specific, meaning they're going to act on a specific substrate. And we also mentioned that their activity is affected by temperature, pH, which is potential hydrogen, substrate concentration, enzyme concentration, inhibitors, and cofactors. Okay, so today we're going to go further and look at these factors that affect enzyme activity. So we know that an enzyme has got the ability to speed up the rate of a chemical reaction. We know that it has got the ability to speed up the rate of a chemical reaction. Now, this ability can be affected by temperature. It can be affected by pH, enzyme concentration, substrate concentration, etc. The ability of an enzyme can be altered due to these factors. So, how does temperature affect enzyme activity? Let's find out. So, enzyme activity increases with increase in temperature. Enzyme activity increases with increase in temperature up to the optimum temperature. So what they are saying is that as you increase the temperature, the activity of an enzyme will also do what? It will also increase, but only up to the optimum temperature. Okay, meaning there's a limit at which this increase is going to be consistent. Okay, so as you're increasing the temperature, the activity of an enzyme will also increase, but there's a limit, and the limit is the optimum temperature. Once you go beyond the optimum temperature, something happens. Let's continue. Now, this occurs because an increase in temperature results in increase in the kinetic energy of both the enzyme and the substrate. Now, what you need to know about kinetic energy, my students, is that this is the energy uh, that is as a result of movement. As something is moving, it gains kinetic energy. And as we all know, particles are in constant movement, isn't it? If you look at gases, if you look at gas, liquid, solid, the particles forming up these three states of matter are in constant motion. I'm sure those who take science will agree with me. Now, kinetic energy is energy gained as something is moving. So when you increase the temperature, these enzymes and the substrates are going to gain kinetic energy, leading to them moving at a faster rate. And since they are now moving at a faster rate, it will increase their ability to combine and form a product. So when you increase the temperature, what you just need to know is that it will also it will lead to activity of an enzyme, because now it will speed up the rate of a reaction at a faster rate. Okay, so what we're simply trying to say here is that increase in temperature leads to an increase in the activity of an enzyme up to the optimum temperature. Okay, so at temperatures lower than the optimum, okay, let me read that again. At temperatures lower than the optimum, the rate of an enzyme catalyzed reaction doubles with every increase of 10 degrees Celsius. So when you increase 10 degrees Celsius, the activity of an enzyme doubles. So if you are at 10 degrees Celsius, you increase, you go to 20 degrees Celsius, you increase the temperature, the activity of an enzyme will do what? It will double. If you go from 20, you go to 30, the activity of an enzyme, it will do what? It will double, okay? I hope you are following. It will double as long as you are below the optimum temperature. So as you are below the optimum temperature, as you increase by 10 degrees Celsius, that will lead to an increase, or that will lead to the activity of an enzyme. It will double. The activity of an enzyme, it will double as you increase the temperature by 10 degrees Celsius below the optimum temperature. So I hope you can see my mouse. Is there a way I can increase this? Let me see. Okay, I don't think there is. So I hope you can see my mouse. If you look at our graph here, the optimum temperature is there. Can you see? Can you clearly see my mouse? Is my mouse visible on your end? Because I'll be using it to explain. I hope you can see. So this is the optimum temperature. And going down this side, we are below the optimum temperature. Okay? This is below the optimum temperature. So the temperature is increasing. Let me do this. The temperature is increasing as we move from this end going to this end. The temperature is doing what? Increasing. And here at this point, the temperature which is here, let's say for human beings, you and I, the optimum temperature is approximately 37 degrees. Okay, so at this point, at this blue point that I've written here, this is the optimum temperature. And imagine that's where 37 degrees Celsius is. So that's the optimum temperature. Okay, once the temperature goes beyond 37 degrees Celsius, something happens. Meaning once the temperature increases beyond 37, it goes to 38, 39, 40, something happens. But if we are below 37 degrees Celsius, every increase of 10 degrees Celsius will lead to the to an enzyme activity. It will double the activity of an enzyme. Let me say that again. If we are below the optimum temperature, every increase in temperature by 10 degrees Celsius, it will double the activity of an enzyme. Okay? As long as we are below the optimum temperature, every increase of 10 degrees Celsius, it will double the activity of an enzyme as long as we are below the optimum temperature. So, like I said, this is 37 degrees. So if we increase from 10 to 20, what will happen? The activity of an enzyme will double. From 20 to 30, the activity of an enzyme will double. From 30 to 40, the activity of an enzyme. So now, 30 to 40, there, we are now going to go above the optimum temperature. So in that case, it won't double, because 30 to 40, as we are increasing the temperature, we are even going to surpass the optimum temperature. So in that case, the activity of an enzyme won't double. I hope we're clear with that statement, my students. If you're behind, make sure that you ask in the comment section. Yeah, ask. So let's continue. The activity, okay, before we go to the activity, the optimum temperature, let's define the optimum temperature. So here, I'm here. The optimum temperature is the temperature at which an enzyme works best. The optimum temperature is the temperature at which an enzyme works best. So if you look at our graph here, we've got temperature on the x-axis, and then we've got rate of enzyme catalyzed reaction on the y-axis. In other words, we've got the activity, the rate, the speed, okay, at which an enzyme is catalyzing a reaction on the y-axis. So on the x-axis, we've got temperature. On the y-axis, we've got the rate of enzyme catalyzed reaction. In other words, the speed at which an enzyme is catalyzing a reaction. So if we increase temperature, let's say this is 10, okay, this is 10, and then this is, let me put it here, this is 20, and then this is 30, right? I'm using a mouse, bear with me. So this is 10, 20, 30, and then we've got 37 degrees here, okay, 37 degrees. So we've got 10, 20, 30, then we have 37 degrees, and then I can say 40, 40. Let's do that. Let me say 40. Okay, so on the x-axis we've got temperature, and then on the y-axis we've got speed. So if we increase the temperature by 10 degrees, we said that the activity of an enzyme doubles, right? So if you are to plot, or if you were to finish up this graph, it will look like this. Okay, and then if we increase 10 degrees, what will happen? The activity of an enzyme will also increase on the y-axis. So we've moved from this point to this point after increasing the temperature. If we increase the temperature again from this point to this point, what will happen to the rate of the enzyme? It will also increase, as you can see. It will also do what? Increase. So as we are increasing the temperature, the rate of the enzyme is also doing what? It's also increasing. The rate of the reaction is also increasing. And then once we reach the optimum temperature, this is the highest point, optimum temperature. And we've defined the optimum temperature to be the temperature at which an enzyme works best. So once the temperature reaches the optimum temperature, what will happen to the rate of the reaction? It will increase. And at this point, it is going to be so fast, because at this point, which is the optimum temperature, an enzyme is working at its best. But once what demo is not clear, okay, I'm going to repeat. I'll repeat. Don't worry. I'll repeat. So once we go beyond the optimum temperature, like here, let me say we've got, so this is 37. Remember, we agreed that this is 37 degrees. So if, let's say this is 39, okay. Once we go beyond the optimum temperature, what will happen to the rate of the catalyzed reaction? It will reduce. It reduces, because we've now gone beyond the optimum temperature. Okay, so optimum temperature, it is just the temperature at which an enzyme works best. And then they are saying that the activity reduces, okay, the activity reduces after the optimum temperature, because the enzyme gets denatured and loses its catalytic function. So once the temperature goes beyond the optimum temperature, then it will lead to an enzyme being denatured, meaning the shape of an enzyme will change, making it to lose its ability to catalyze a reaction. So what am I saying to summarize everything? How does temperature affect the activity of an enzyme? Well, when you're increasing the temperature, that will lead to an increase in the activity of an enzyme, but only up to the optimum temperature. Once you reach the optimum temperature, the enzyme will work at its best. But when the temperature goes beyond the optimum temperature, an enzyme will be denatured, it will be destroyed, and it will lose its ability to speed up the rate of the chemical reaction. That's a summary. Okay? Utemwe. That's the summary. I'll say it again. How does temperature affect the activity of an enzyme? So here's how it affects. An increase in temperature will lead to an increase in the rate of a catalyzed reaction. Or in other words, it will lead to an increase in the activity of an enzyme, but only up to the optimum temperature. Okay, so as you are increasing the temperature up to the optimum temperature, as you are increasing, the rate of the reaction is also increasing, but only up to the optimum temperature. Once the temperature goes beyond the optimum temperature, then the enzyme would be denatured. It will be destroyed. Therefore, it will lose its ability to speed up the rate of the reaction. That is why when you look at our graph, at this point, it was at 10 degrees, right? We've increased the temperature. After increasing the temperature, what has happened? Even the rate of the reaction has increased. After moving from 20, we've gone to 30. What has happened? The rate of the reaction has also increased until we've reached the optimum temperature. But after going beyond the optimum temperature, which is here, we said this is 39, what has happened? The rate of the reaction has now started reducing because we've gone beyond the optimum temperature, and the enzyme is now losing its ability to speed up the rate of the reaction. Okay, so I can see a question. Let me just attend to it from Juliet. So both increase and decrease in temperature denatures the enzyme. Not so. No, 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 no. Decrease in temperature will only slow down the ability of an enzyme to catalyze the reaction. What I mean is, when it's below the optimum temperature, an enzyme will still have its shape. It won't be denatured. It will still have its shape. As long as you're below the optimum temperature, an enzyme will still have its ability to catalyze, but it won't just catalyze at a good rate when you're below the optimum temperature. So I'll say that again. If the temperature is below the optimum temperature, an enzyme will still have its ability to catalyze, but it won't just work at its best since it is below the optimum temperature. Once it reaches the optimum temperature, that enzyme will now act at its best. It will be able to speed up the rate of the reaction at a good rate because it's now working at its best. But when the temperature goes beyond the optimum temperature, now the enzyme will be denatured, meaning it will be destroyed, losing its ability to function. Okay, losing its ability to do what? To function. Are you clear, Juliet? Okay, okay. So that's what that's what we're saying here. If the temperature is below the optimum temperature, the enzyme will still have its ability to function. But once the temperature goes beyond the optimum temperature, the enzyme will be denatured and it will lose its ability to function. So enzyme denaturation is the disturbance of the shape of an enzyme and its active site, such that the substrate no longer fits in the active site. Hence, the enzyme can no longer carry out its catalytic function because it has been destroyed, it has been denatured, and the active site, the shape of the active site has changed. So I hope we're clear with temperature, how it affects. So all you need to know is that increase in temperature will result in what? Increase in the activity of an enzyme up to the optimum temperature. Because once the temperature goes beyond the optimum temperature, that enzyme is going to be destroyed. So I can move on to pH now, right? Can I move on to pH? And I'll give an example of some washing powder. Like there are some, if you're washing, they'll even say you should wash using warm water. Because in soap, the one that we use, washing powder, boom paste, there are enzymes in there. Enzymes that are going to speed up the process of removing the stains on the clothes. Okay, so as you're washing, if you're washing without soap, it will take time for you to remove those stains, right? But once you introduce the soap or the boom paste or the washing powder, you find that it will be faster, isn't it? And you find that there are some products like boom paste, they will say that no, you should use warm water as you're washing, or maybe you should use cold water. All that is to ensure that the enzymes that are in that product, okay, they are working at their best. So you need to ensure that the temperature is also good for the activity of the enzymes found in those detergent pastes that you're using. Okay, so I can move on to. So what we need to know is that pH is a measure of how acidic or alkaline a substance is. So how acidic or alkaline a substance is, that's what pH is. How acidic or alkaline a substance is. Okay, so pH values range from 1 to 14. So if we're talking about pH reading, my students, we're simply trying to measure how acidic or alkaline a substance is. Is this thing acidic or is this thing alkaline? Is the environment acidic or is the environment alkaline? We use pH to measure, okay? And the pH values, they range from 1 to 14. A pH value of 7 is said to be neutral. So for example, water is neutral. Okay, it is not acidic, it is not alkaline, it is neutral. Therefore, the pH value for water is 7. Okay, because 7 is a pH value which is said to be neutral. And then pH values which are lower than 7 are said to be acidic, while values higher than 7 are said to be alkaline. So the pH values that are below 7 are acidic, and then those above 7 are alkaline. This means that activity increases as pH values get lower than 7, and alkalinity increases as pH values get higher than 7. I will explain. So what they mean here is that as we are moving from 7 going down, the acidity of a substance increases. What does that mean? 6 is acidic, but 5 is more acidic. So 6 is acidic, right? Slightly acidic, because we're moving from neutral. So 6 is acidic, but not so acidic. It's close to neutral, but it's acidic. So 5 is more acidic than 6. 5 is what? More acidic than 6. And 4 is more acidic than 5. 4 is more acidic than 5. 3 is more acidic than 4. Okay? 3 is more acidic than 4. 2 is more acidic than 3. 2, it's more acidic than 3. And 1 is more acidic than 2. So if you put something in acid that has got a pH value of 1, it will melt, because 1 is a pH value which indicates something to be too acidic, whereby if you were to put your hand in that acid, it will melt. So the idea here is that as we are going down the pH values, as the pH values are decreasing from 7, something is becoming more acidic. Okay, as the pH values are going below, as they are decreasing, the acidity of a substance increases. But as alkaline, but not too alkaline, it is slightly alkaline. 9 is alkaline, which is more than 8. It is more alkaline than 8. 10 is more alkaline than 9. 11 is more alkaline than 10. 12 is more alkaline than 11. 13 is more alkaline than 12. 14 is more alkaline than 13. So as we are increasing the numbers from 7 going to 14, something is becoming more alkaline. That's what they mean here when they said this means that acidity increases as pH values get lower than 7, and alkalinity increases as pH values get higher than 7. I hope we're clear, and I hope we understand the pH value. Okay, so pH value is just the measure of how acidic or alkaline a substance is. So when it comes to environments, they've got different pH values. So if we are in an acidic environment, that acidic environment can have a certain pH value. Maybe the pH value of that acidic environment is 5, or maybe it is 4, or maybe it is 3, the pH value of that acidic environment. If an environment is alkaline, that the pH values, I'm now here, okay, I'm now here. The pH value at which a given enzyme works best is called the optimum pH. The pH value at which a given enzyme works best is called the optimum pH. So when it comes to enzymes, my excellent students, there are enzymes that are active in an alkaline environment, and there are those that are active in an acidic environment. So if you get an enzyme which can work best in an acidic environment, you put it in an alkaline environment, nothing will happen. It won't be active. Likewise, if you get an enzyme which works best in an alkaline environment, you put it in an acidic environment, nothing will happen. It won't be active, because enzymes will work best in an environment which is suitable for their activity. So I'll give an example, but before I give an example, what they are saying here is that for each given enzyme, it has got its own optimum pH. Okay, for each given enzyme, it has got its own optimum pH, meaning it has got its own pH value at which it will act at its best. Each given enzyme, my enzymes yamenea must speed up my rate of the reaction. They have their own optimum pH at which they will act at their best. So if the optimum pH of a specific enzyme is 4, okay, meaning when the optimum pH is 4, that enzyme will act at its best. If we go below the optimum pH or above the optimum pH, then what will happen? That enzyme won't work at its best. I hope you are following. And then also remember that as we are going down from 7, 6, 5, 4, 3, 2, 1, the acidity is increasing. And as we are going up, 8, 9, 10, 11, 12, 13, 14, the alkalinity is increasing. Keep that in mind. Keep that in mind. Now, let's continue. We're here. So values lower or higher than the optimum pH, lower enzyme activity. I want you to so imagine we've got an enzyme, right? And the optimum pH of that enzyme is 4. 4. Let me even mark it. Imagine the optimum pH for that particular enzyme is 4. Right? 4. 4 is the optimum pH, meaning if the pH value is at 4, that enzyme will act at its best because 4 is the optimum pH for that specific enzyme. So if we increase, we go per 3, because remember, as we are going down, what are we doing? We're increasing the acidity. So if we increase, if the pH value moves from 4 to 3, meaning we increase the acidity, what will happen? The activity of that enzyme, it will be lowered. It will become less. It won't be that active because we've now gone beyond the optimum pH. We've gone at 3. Okay. Likewise, if we move from 4, which is the optimum pH, we decrease, we go at 5. What has happened? We've lowered the acidity, isn't it? What will happen to the activity of an enzyme? It will also decrease. It will also go down. It will also decrease. because values lower or higher than the optimum pH lower enzyme activity. Are we clear? Are we clear? Are we clear, my excellent students? Are we clear? Wonderful. So, optimum pH is specific for enzymes. So each given enzyme, it has got its own specific optimum pH. Once you go beyond, in this case, going beyond means going less, right? Because as we are going down, we're increasing the acidity. So if we increase the acidity, we move from 4 to 3 when the optimum pH is 4. What will happen to the activity of an enzyme? It will be lowered. And likewise, if we go, if we lessen the acidity, okay, meaning we move from 4 to 5, what will happen to the activity of an enzyme? It will also be lowered. Likewise, if the optimum pH of an enzyme is 10 or it's 11, remember, on the side for alkaline, as we are going up, we move from 8, 9, 10, 11, 12. As we are going up, what is happening to the alkalinity? It is increasing. But as we are going down, we move, if we're moving 14, 13, 12, 11, 10, 9, what is happening to the alkalinity? It is decreasing. Okay. So if the optimum pH is 11 and then we go to 12, the alkalinity increases to 12. What will happen to that enzyme which works at its best at 11? The activity will be lowered. Likewise, if the optimum pH is 11 and then we decrease, we go at 10, the alkalinity decreases and it goes at 10, the activity of that enzyme will be lowered. So keep that in mind. So the optimum pH varies from enzyme to enzyme, depending on the enzyme's natural occurrence. For instance, the digestive enzymes of the stomach work best at acidic pH values, while those of the duodenum work best at alkaline pH values. Okay, so in the stomach, the stomach is an acidic environment. You will learn this later on this same month when we look at nutrition in animals. You will know that the stomach is an acidic environment. Therefore, the enzymes that are found inside the stomach, they work best in an acidic environment. So if you get that enzyme which works best in an acidic environment, you put it in an alkaline environment, it won't be active. Okay? So, yeah. For instance, the digestive enzymes of the stomach work best at acidic pH values, while those of the duodenum work best at alkaline pH values. Okay. A graph of enzyme activity against pH is always symmetrical and has its peak at the optimum pH as illustrated by the following diagram. Let's look at the diagram. Let's look at the diagram. So this is the diagram. And as you can see, there's a difference between this diagram. Okay, look at the diagram. You will notice that there's a difference between the diagram for pH and the diagram for temperature. So if you look at the diagram for temperature, it will increase and then it will decrease instantly. It will be increasing slowly, and then it will decrease instantly. Okay, but if you look at this one, it is equal on the side, on the left side and on the right side. It is equal, and optimum pH is just on the middle, meaning if we increase the pH value or we decrease the pH value, we go beyond the optimum temperature or we go below the optimum temperature, the reduction will be, it will be the same in the activity of an enzyme. So this is how the diagram, or this is how the graph for pH looks like. Can we move on? Can we move on, my excellent students, to enzyme concentration? Godfrey said I should move on. Okay, wonderful. Otherwise, if you've got questions, feel free to ask. This is the time, yeah? This is the time to ask. So when it comes to, so we've looked at temperature as well as pH. Now let's look at enzyme concentration. So the rate of an enzyme catalyzed reaction increases with increase in the concentration of the enzyme and remains constant when there are no more free substrate molecules for the enzyme to act on. So what do they mean here? What do they mean? If we have got an enzyme, right? One enzyme. Let me just do a dot. Imagine we've got one enzyme, yeah, right? So utemwa is not clear on the pH. Okay, let me just go a little bit back by the pH, just a little bit. So on pH utemwe, what you need to know is that one, enzymes have got specific optimum pH values. So if an enzyme has got an optimum pH value of 4, okay, first of all, we know that 4 is it is a pH value for an acidic environment. And if we move from 4, we go to 3, that simply means we're increasing the acidity. So if we increase the value, the pH value, we go beyond 4, which is the optimum pH value for a specific enzyme. If we go at 3, that simply means we're increasing the acidity. And since we're increasing, the pH value is increasing, that simply means the activity of an enzyme will be lowered. Likewise, if we go at 5, we move from 4 to 5, what will happen? That simply means we're reducing the acidity. And since we're reducing the acidity, we're going down the optimum pH, then that will also lead to the reduction in the activity of an enzyme. So what you just need to know is that each enzyme has got a specific pH value. So in this case, if the optimum pH value for a specific enzyme is 4, when we go at 3, if we increase the acidity, we move it to 3, the activity of that enzyme will be reduced. And if we move from 4, we go at 5, the activity of that enzyme will reduce, because now we are increasing the value or decreasing the value of the optimum pH, of the pH, which will now lead to a decrease in the activity of an enzyme. I hope I'm making sense. Likewise, if the optimum pH value of an enzyme that works in an alkaline environment is 11, when we increase, we move from 11 to 12, that will reduce the activity of that enzyme. And when we decrease from 11 to 10, that will decrease the activity of that enzyme, because that enzyme can only work at its best at 11. That's where it can only work at its best, at 11. So if we increase it, we move from 11 to 12, that will lead to a reduction in the activity of that enzyme. And if we reduce it, we go at 10, that will also lead to a reduction in the activity of an enzyme. So it just has to be at 11. If we increase or decrease the value, the activity of that enzyme will reduce. So the optimum pH is 11, therefore it will only work at its best at 11. When you increase it to 12, the activity will reduce. When you reduce it to 10, the activity of an enzyme will reduce. That's how pH pH affects enzyme activity. And what I'm saying is illustrated in this graph. You've seen this part, which is the optimum pH, right? If we go this side, if we increase the pH value, we start moving this side, what will happen? The activity is going to reduce. So for example, let me just erase. So for example, let's say the pH value is 4, right? or let me stick to 11. Imagine this is 11. Okay, that's the optimum pH value. Just a minute. So the optimum pH value is 11, and then we've got 12. Say 12, 1, and then 2, and then we've got 10. This is 10, like that, 10. Then here we've got 13. So bear with me, I'm using a mouse. So we've got 13, and then here we've got 9. So this is the optimum pH value for a specific enzyme that works best in an alkaline environment. This is the optimum temperature. I mean optimum pH, 11. So if we increase, we go at 12. What will happen to the activity? Let's find out. It reduces, isn't it? Though my lines are not that straight, but you get the point, right? At 11, when we're at 11, the enzyme will work at its best, and the rate of the reaction will be fast, as you can see, at 11. But when we go at 12, that will lead to the reduction in the activity of an enzyme. Likewise, if we reduce, we move from 11 to 10, what will happen? The same thing will happen. There will be a reduction in the activity of an enzyme, meaning the activity of an enzyme will only be at its best at the optimum pH. If you increase or reduce, it will lead to a reduction in the activity of an enzyme. If we move from 12 to 13, it will further lead to a reduction in the activity of an enzyme. Therefore, the rate of this reaction will be slow, like that. If we move from 11 to 9, again, the activity of an enzyme will be so slow, it will reduce. Unless we are just at 11, the pH, optimum pH is just at 11, then it will be at its best, like as we are seeing there. Are you now clear with Temwe? I hope it's clear, my students. I hope it's clear. I hope it's clear. Are we clear otherwise? So when it comes to pH, it just needs to be at the optimum pH. When you increase or decrease the pH value, that will lead to a reduction in the activity of an enzyme. So the way it is, if the optimum pH is 11, when we increase it to 12, that will lead in the reduction that will lead to a reduction in the activity of an enzyme. When you reduce it from 11, you reduce it to 10, again, it will lead to a reduction in the activity of an enzyme. That is why here it was saying that, let me just go back. That is why here it was saying that values, okay, values lower or higher than the optimum pH, they do what? They lower enzyme activity. Values lower or higher than the optimum pH will do what? Will lower enzyme activity. I'll read that again, and this is what should stick in your mind. Okay, Godfrey, please, sir, I have a question that I will. Okay, no pressure. In fact, you can actually ask right now because I'm almost done. It's almost 21, and I'm sure there's science. So you can just quickly type it. If not, you can send in the group. In fact, just ask in the group, and then I'll be able to respond. So my students, keep this statement in your mind when it comes to optimum pH, or when it comes to pH in general. Values lower or higher than optimum pH, what do? They lower enzyme activity. Values lower or higher than the optimum pH, lower enzyme activity. So if the optimum pH is 11, when we increase the value, what is it saying? Values higher, they do what? They lower enzyme activity. And if we go below 10, if we go below 11, we go at 10, what is it saying? Values lower than the optimum pH reduce or they lower enzyme activity. So keep that in mind under pH. Keep that in mind. And my time is now almost up, so I won't be able to talk about enzyme concentration. So meaning tomorrow we need to have another live class. Tomorrow we're going to have another live class so that I can finish up these factors. So in tomorrow's live class, I'll talk about enzyme concentration, substrate concentration, inhibitors, and then cofactors. Yeah, so for tonight, I think we can end here. Okay, Utemo is clear. Wonderful, wonderful. I'm happy that you are clear. So Godfrey, make sure that you ask that question. Yeah, ask me that question in the group. I will be able to respond to you. So we can end here, my excellent students. It's now 21. It's almost 21 actually. So we can end here for tonight. Otherwise, I hope you've understood. I hope you've enjoyed this live class. Make sure that you join tomorrow. Do not miss these live classes. You have to be participating. Join these live classes. Please, I beg of you. I beg of you. Join the live classes. Don't miss them. All right. You have a good night.